All right, today we're going to talk about the difference between rectangles, squares, and a rhombus or rhombi. We're going to talk about the ins and outs of each one, and you guys kind of need to know the differences because they each have different properties. We are still going to talk about them according to their sides, the angles, and the diagonals inside of them. But these three kind of go together. So a rectangle, all right, you should know this is a rectangle. It's kind of like an elongated square. A square, you guys should know, have four equal sides. The rectangle, these are the same. These are the same. The square, all four sides are the same. And a rhombus, I like to think of as a slanted square. Okay? So slanted square, still all the sides are the same, but we no longer have these 90-degree angles. Okay, and that kind of throws some things off, and we'll talk about the differences between those rectangles, square, and rhombi. All right, so rectangle, if you look at a rectangle, things we know, the sides, opposite sides, are congruent. All right, so they are congruent, so you can mark those, all right, like we just did over there. The angles are important as well. Inside of a rectangle, the angles are all 90 degrees. All right, so you guys should know that these are all 90 degrees. Then the diagonals, okay, because this is a parallelogram, all right, it is still a parallelogram, they bisect each other. So it's a parallelogram, so just by the one that we did earlier, they bisect each other. And then to add to it, in this case, the diagonals are congruent. So we're adding this step. That's what's special about a rectangle. Okay? Parallelogram doesn't necessarily need 90-degree angles, but when they are 90 degrees, it's a rectangle, and now my diagonals are congruent. The way that we get that is Pythagorean theorem. Okay, again, if this is 4 and this is 10, well, we'll do an easier one. So let's say a 3, a 4, then my hypotenuse would be 5. If you do the other one on this side, all right, well, this is a 3, a 4 again, my hypotenuse would still be the same. So they bisect each other, and they are congruent. That's different from a parallelogram. So if we draw our diagonals, these are all the same. All the diagonals, all of those sections are the same. So the one going down from left to right, this guy is the same as this guy, which was different in just a parallelogram. All right, so that's a rectangle. So we're just going to take that rectangle and we're going to kind of add more to it. So when we talk about a rectangle, now we're going to adjust it to a square. So a square has all sides congruent. Okay? Again, this is still a parallelogram, but now we're a little bit more specific than a rectangle. We're saying all the sides are congruent, and that kind of throws in a few more lists there. So now we know all the sides are congruent. You guys should know that the angles are all 90 degrees. All right? So these angles are all 90 degrees. All right? And because a square is actually a rectangle, all right, a square is a rectangle is not always a square, then it has the same rules for the diagonals. It bisects each other. They are congruent, so the diagonals are congruent. And then we have a few more things. The diagonals are actually perpendicular. All right, so the diagonals are perpendicular, and there's one more thing. Bisects the angles. So all right, so these are the two new ones that come in with a square. So the diagonals are, they bisect each other. They are congruent, which is the same as a rectangle. But the two new ones, Now they intersect at a 90-degree angle, and now they bisect the angle. So here we're going to draw our diagonal. Okay, we know just by the stuff that we talked about that these are all the same. Okay, they bisect each other and are congruent, so they're all the same. The new thing that is in there, this is a 90-degree angle. All right, so they intersect at perpendicular in the middle. And then the other new thing, it bisects this angle. So this angle is 45 and 45. So all these angles around here are 45, 45. What this leads into is we're going to start using those special right triangles, and we'll get into some of that in the class. All right. Right now we have our rhombus. All right, our rhombus, again, I like to call a slanted square. Okay, is still a parallelogram. All right, so, and it's a square, so it loses the angle part, but the sides stay the same. So 4 congruent sides. So all these sides are the same. All right, and then we go to the angles. The angles are just like a parallelogram. So the opposite angles are congruent. Consecutive angles are 180 degrees or supplementary. All right, so that one there is the same as a parallelogram. The diagonals, all right, they do bisect each other, which is just like a parallelogram. They are congruent, and they are perpendicular. All right, so they are the same length. And they are perpendicular to each other, which is new from just a regular parallelogram. And then they also bisect the angles. All right, so if you compare a rhombus, the diagonals are the same. They bisect each other. Let me see. All right, so if you compare just the diagonals, just this part here, they bisect each other. All right, so we got that. They bisect each other. They are congruent. They intersect at a 90-degree angle, and they bisect the angle. So those diagonals are the same. They all have 4 congruent sides. The only thing that's different between a square and a rhombus are these guys here. So this guy here, the angles are just like a parallelogram. They are opposite are congruent, consecutive add up to 180, but still the diagonals interact the same way as a square. So we have a rhombus, a square, and a rectangle. Rectangle adds the new idea that diagonals are congruent. That's not the case in a parallelogram. All right, and we'll do some of these problems in class.